Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a plus b is equals to 8 and ab is equals to 48. And we solve this problem for all the values of a and b, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And here we call this is our equation number 1 and this is our equation number 2. So first we focus on equation number 1, and equation number 1 implies that here we move the term plus a to the right hand side and we get the value of b is equals to 8 minus a, and we called this is our equation number 3. So here we just use this equation number 3 in equation number 2, so that our equation number 2 is implies that we put the value of b here and it will becomes a times of 8 minus a is equals to 48. And now further in the next step we need more simplifications here, and we multiply this a separately on both of these two values, and we get 8 times 8 is equals to 8a minus a times a is equals to a square, and this is equals to 48. And now further in the next step we need to write this into the standard form, and for this we move all the terms from left hand side to the right hand side, and we get this is minus a square becomes plus a square, this is plus 8a becomes minus 8a, and this is plus 48, and this whole equation is equals to 0. So you see that after this little bit simplification, we convert our given question into the quadratic form. So here we need to solve this quadratic equation for the values of a, and then we use these values in equation number 3 and we get the values of b. So you know about that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we use the quadratic formula to solve this type of question. So now first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 8, and c is equals to plus 48. And we state the quadratic formula as a equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and here we substitute all the values of a, b and c. So when we put the value of b here, we get this is minus b becomes minus times minus 8 plus minus square root of b square, it is minus 8 square minus 4 times of a is 1 and c is 48, and it is divided by 2 times of a, and here our a is equals to 1. And now in the next step we have minus times minus becomes plus 8 plus minus square root of minus 8 square becomes 64 minus 4 times of 48 is equals to 4 8s are 32. We write 2 and carry 3. 4 4s are 16. 16 plus 3 becomes 19. So we get 192, and it is divided by 2 times of 1 is equals to 2. So further we subtract these two values and we get 8 plus minus square root of minus 128. When we subtract these two values we get minus 128. And here we just break the square root sign and we apply this separately on both of these two values, and we get 8 plus minus square root of, we break this 128 as 64 times of 2 into square root of minus 1 divided by 2. Further we have a is equals to 8 plus minus, here we apply square root on both of these two terms, and we know that square root of 64 becomes 8 times of square root of 2, and square root of minus 1 becomes iota, and we apply these two separately on both of these two values, and we get, from here we get 4 plus minus, this is also 2 times 4 becomes 8, and we get 4 times of square root of 2 into iota. These are the two complex roots of the given equation. which we get here from first method. So we use these two values of a and we get the values of b. So here we write the positive value, it is 4 plus 4 times of square root of 2 iota, and here we write the negative value, it is 4 minus 4 times of square root of 2 into iota. So we copy down equation number 3 here, it is b equals to 8 minus a. This is the equation number 3. Again we write it here, b equals to 8 minus a. And here we put, when we put this value of a here, we get b is equals to 8 minus 4 plus 4 times of square root of 2 iota, and we multiply negative sign on both of these two values and we get 8 minus 4 times of square root of 2 into iota. So we get the value of b is equals to 8 minus 4 becomes 4 minus 4 times of square root of 2 into iota. This is the value of b. Corresponding to the value of a is this one. So here we get the first order pair of the root is equals to 4 plus 4 times of square root of 2 into iota and 4 minus 4 times of square root of 2 into iota. And now we move towards our second case, and here when you put this value of b here, we get a. When you put this value of a here, we get b is equals to 8 minus a. The value of a is 4 minus 4 times of square root of 2 into iota. Further we have b is equals to, we multiply this negative sign on each of these values and we get 8 minus 4 plus 4 times of square root of 2 into iota, and we get b is equals to 8 minus 4 becomes 4 plus 4 times of square root of 2 into iota. So this is the value of b. Corresponding to the value of a is this one. And finally we have the second pair of roots of the given equation are, the value of a is 4 minus 4 times of square root of 2 iota. The value of b is 4 plus 4 times of square root of 2 into iota. So these are the two roots of the given equation which we get here. And now in the next steps, we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of these roots, we need to copy down given question statement here. And here we write the first equation, that is a plus b equals to 8. And here we write the second equation, that is a plus b is equals to 48. And now I can just verify the first root only, and I can left the verification process of the second root by do yourself. Okay. So now here for verification of this, we substitute a is equals to this value and b is equals to this value. We put both of these two values on both of these two equations and we get the value of a is 4 plus 4 times of square root of 2 iota, and the value of b is 4 minus 4 times of square root of 2 into iota, and we check that is this equals to 8 or not. So this is the negative term, this is the positive term are cancelled out by each other and we get 4 plus 4 becomes 8 equals to 8. So clearly the first root satisfied the first equation, and now in the same pattern we verify the second equation, and here we put the value of a, it is 4 plus 4 times of square root of 2 into iota and 4 minus 4 times of square root of 2 into iota, and we check that is this equals to 48 or not. Here we use the nice algebraic formula and we write 4 square minus 4 times of square root of 2 iota square is equals to 48. 4 square becomes 16 and this 4 square becomes 16, and the square of square root of 2 becomes 2 and the square of iota square it is equals to 48, and we have 16. We know that the value of iota square is minus 1, so this minus and minus becomes plus, and 16 times 2 becomes 32 is equals to 48, and we easily get 48 equals to 48. So the first root satisfied both of these two equations, and similarly you check the second one, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.